I want to tell you about as much as I understand about a Feynman inverse sprinkler. So a regular S-shaped sprinkler will move away from the bend, so this one will move counterclockwise. But what do you think would happen if the sprinkler were made to suck water in instead? Would it still spin counterclockwise, or would it switch directions and now spin clockwise? There's also the option that it doesn't spin, but you only get two options on these sticker poles. The first physicist to write about the inverse sprinkler problem was Austrian physicist Ernst Mach, who made a contraption illustrated here in 1883. When you squeeze on the rubber ball, air flows out and it spins away from the bend, so in this case it'll rotate clockwise. And when you release the ball, it sucks in air. Ernst wrote that the device showed no distinct rotation when it was sucking air in. Then in the 1940s, apparently unaware of Mach's work, the Princeton Department of Physics was debating the problem. And a young Richard Feynman set up a reverse sprinkler experiment inside a carboy at the university's cyclotron laboratory. He mentioned the experiment in his memoir. Surely you're joking, Mr. Feynman, but he didn't mention the results. He only made arguments for why it would spin either direction. Regardless, appearing in his book popularized the problem, and now it's commonly called the Feynman sprinkler. But after he died, two separate people who were there wrote about what happened that day. There was a little tremor, and the sprinkler had moved back to its original position and stayed there. And when they turned up the pressure to increase the flow, the sprinkler stayed put, not rotating, until the carboy exploded due to internal pressure. So far, that's two experiments with no distinct rotation, and what's up with that? Part of what's up with that is that sucking isn't simply the opposite of blowing. Like, check this out. If I blow through the straw, it creates a jet of air that hits the bend and comes out in a uniform direction, like a fire hose. But sucking on it doesn't propel the straw forward or backward. One key difference, as I've heard it explained, is that air coming in is coming in from all directions. If I put my hand in front of the fan, I feel the jet of air pushing against my hand. But if I put my hand on the other side, I don't feel the air getting pulled through. And that's because it's not as directional. Air is getting pulled through from all around. So sucking is far weaker than blowing. In fact, when the experiment's done with really good bearings and a fast inflow rate, it does go backwards, just way slowlier. So like this versus this. And this is the part where my understanding of the problem is limited, and physicists themselves seem to disagree with each other about it. Some say it's the viscosity of the fluid that's responsible for the spin or lack of spin. And some say in ideal conditions with a steady inflow there won't be a spin at all. And it's a series of vortexes inside the nozzle that causes one. There's vector diagrams and lengthy explanations, and I just can't decide who's right, and it's been a long time that I've been thinking about this.